Hi friends, Unit 1, Day 6. We are finishing out our steps to solving radical equations. We've got 3 example problems left, 13, 14, 15. So for this one, we're now seeing something besides a square root. Now we have a cubed root. Again, the process is the same. We want to get the radicals to each side. So when we take, in this case, not the square, but when we take the cube of both sides, that we end up eliminating our cubic roots. So here I have the cubed root of 4x squared minus 4x plus 1 is equal to the cubed root of x. So now, again, to eliminate the cube root, we're going to raise both sides to the third power, or cube it. So now I have 4x squared minus 4x plus 1 is equal to x. Get everything by itself, so I'm going to subtract x on both sides. Minus x. So I have 4x squared minus 5x plus 1 is equal to 0. Now let's see. Find my two values. Let's see, that's plus. They're both going to be minus minus. Looks like I'm probably going to go with a 4x minus 1 and then an x minus 1. Let's see if that works. Yep, looks like that's going to work. Now I'm going to set these equal to 0 and then solve. So 4x minus 1 equaling 0 and x minus 1 equaling 0. Add 1 on both sides. 4x equals 1. Divide by 4, so I have x equals 1/4. Add 1 on both sides. X equals 1. Now, I do not need to check the domain for a cube root because the cube root's domain is all real numbers. So I know whatever values I end up with, I'm okay. I would probably want to check to make sure this is a valid answer, which you're welcome to do. 14. This one looks a little bit tricky because now it's to the 3/5 power. Remember, to undo something, we need to raise it to the reciprocal power. So in this case, if I raise x to the 3/5, if I raise it to the 5/3 power, that will undo the 3/5. If I do it on one side, I have to do it on the other side as well. So on this left-hand side, we end up with just x. Be careful. My index on this is 5. That's an odd index, so I don't need to worry about possible solutions. If this was an even index, then you would have to worry about possible solution sets. So be careful that your index, in this case the denominator of this rational exponent, is even, then you need to check. Check domain. This one we don't because it's odd. So then 27 to the 5/3 power. A lot of students are like, what do I do? 27 to the 5/3 power. Grab your calculator if you want. I see that it's the cubed root of 27, so I know that's 3. So I'm just going to have 3 to the 5th power, and I wish I knew what that was off the top of my head. I'm going to grab my calculator, my handy-dandy calculator, and 3 to the 5th power is 243. So I get x equals 243. Now for the last problem, I have x minus 4 quantity to the 2/3 power, and then equaling 16. With this one, all we need to do is just raise both sides to the 3/2 power. So I have x minus 4 to the 2/3 equaling 16. All right, so when we raise both sides to the 3/2 power, when you think about what we're doing, this is going to have this has an even denominator. So if you think about it, we're taking the square root. So we need to keep that in mind as we approach this problem. If we're taking this an even root, remember, if we take the square root, we're introducing this. We're introducing an even power. So check. So if you're introducing an even power, an even root, if you're introducing an even root, then we need to check both plus minus. So now I have x minus 4 is equal to plus or minus, let's see, 16 to the 3/2 power. 16 to the 3/2 power. Okay. So now let's go ahead and split this up. Actually, let's simplify this first. I think that's going to be a better bet to go. 16, square root of 16 is 4. 4 cubed, I think, is 256. I don't feel confident with that at all. I apologize. I should know. Nope, 4 cubed is 64. Good thing I checked. So I have x minus 4 equals plus or minus 64. Okay, knowing that, now I can split this up into two parts. But x minus 4 equaling negative 64, and x minus 4 equaling 64. And now these two equations we can solve. Add 4 on both sides, so I get x equals negative 60. And then add 4 on both sides, x equals 68. Because my initial domain had an odd odd root, I don't need to check the domain of this one. So be careful if it's an even. Remember, if it's an even root, you need to check the domain. And if you're introducing an even root, then you need to remember the plus minus. So these are our two solutions. Thank you for joining me in this video. This concludes Chapter 1. Have an amazing day.